Hello! Today we'll be figuring out how to find the inverse of a matrix using the determinant and row reduction. So first, what is an inverse matrix? So an inverse matrix is basically just a matrix that you times by your original matrices, or matrix, to find that will result in I, your identity matrix. So for 2 by 2, that looks like this. So if we keep looking at 2 by 2 matrices, we find that in order to figure out what A inverse is, we have a simple equation here that we can apply to it. So that's going to be 1 over the determinant of your matrix times this matrix here. So your determinant of your matrix is simply just AD minus BC. So if A is equal to A, D being in the top right, D in the bottom right, and C in the bottom left. So when we're trying to find our inverse matrix of this matrix, this is the equation that we can use for that. So an example of this, if A is equal to 3, 1, 2, and 6, you can see what that would look like to find your inverse matrix. So first thing that you can do is you can determine what your determinant is. So in this case, we're going to have 3 times 6 minus 1 times 2, which is going to equal 18 minus 2 times 1 is 2, which equals 16. So plugging that back into this original equation up here, we get A inverse is equal to 1 over your determinant is 16 times 6 in the top left, negative 1, don't forget your negative here, negative 2, and 3. So we see here that these A and D switch, and then B and C stay the same, but they're negative. So if we want to solve that out, we get 6/16, negative 1/16, negative 2/16, and 3/16. Because this here just acts like a scalar, we're going to just multiply by each number. So an easy way to see if you got this right on a quiz or an exam is to multiply your original matrix by your inverse matrix, and it should equal your identity matrix. So do a little multiplication refresher. 2/16 and 3/16. We're going to first start off by finding this A term. So we'll do that by doing this row by this column. So what we'll have here is we're going to have 3 times 6/16 plus 1 times -2/16. -2/16. For our top right one, we will do this top one times the right side of this one. So we're going to have 3 times -1/16 plus 1 times 3/16. And for our bottom left, we'll do this. And then the left side of this equation, 2 times 6/16 plus 6 times -2/16. And finally, our bottom right one, we'll do bottom on this one, and then the right on this side. So 2 times -1/16 and 6 plus 6 times 3/16. So let's simplify that here. And this top one, we'll have 3 times 6, 18/16 minus 2/16. We'll have 3 times -1, -3/16 plus 3/16. We'll have 12/16 minus 12/16 and -2/16 plus 18/16. And as you can see here, these two cancel out, and you're left with 18 minus 2, 16/16, 1, 0, 0, and 1. So we get by, so we know that we have the right inverse matrix here. Nice little check system built in there. So now moving on, we can look at how to find A inverse using row reduction, which is what you end up using most of the time for much bigger matrices. So kind of starting off, we'll do a little refresher on what the row operations are. So your first row operation that you can have is simply swapping rows. The second one you can do is multiply your row by a non-zero scalar. And third, most often used, you can add a scalar multiple of a row to another row. So let's take a look at an example here. Find your inverse matrix. and 0 using row reduction. So when you set this up here, what you want to do to begin with is set up your A, and then on the right side, you're going to put your identity matrix, with your goal being to get this on this side. So the first way that I always like to start off is you want to make this side, right, these two numbers here, 0. So we can start off by using our addition. So we'll do R2 plus negative R1. So the way that I always think about this is this first one that you write is going to be the row that is affected. And then the second, this one right here, is going to just be the scalar of that row. So we know that R1 is going to stay the same. And we know that R3 is going to stay the same. So we'll go on to R2. So 1 minus 1, we got 0. 3 minus 3, 0. 1 minus 0, 1. 0 minus 1, negative 1. 1 minus 0, we got 0. We got 0 minus 0 is 0. So now we want to make this one 0. So in order to do that, we're going to do R3 this time is going to get changed. And we're just going to add R1. Because 1 plus negative 1 will be 0. So we know R1 and R2 will be the same, so we'll rewrite those. R2. So R3, we're going to do R3 plus R1. Negative 1 plus 1 is 0. Negative 2 plus 3 is 1. And then we have 0. We have 0 plus 1 is 1. 0 plus 0 is 0, and 1. So if we see here, we have these two rows pretty much complete, but we want to make this one in the middle up here. So we're just going to simply switch our rows up using our first rule here, swapping rows. We're going to swap R2 and we're going to swap R3. So we know that R1 is going to stay the same. And then we will swap our bottom two rows. We have 0, 1, 0, 1, 0, 1, 0, 0, 1, negative 1, 0, 0. Swap these two. So our last thing that we need to do here is we just need to get rid of this 3, because everything else looks like the identity matrix besides this 3. So we're going to go back to our adding a scalar of multiple rows, and we're going to change this first row, so we're going to write R1, and then we're going to use R2 plus negative 3 R2. So we know we're changing R1, so we'll keep the other ones the same. Make sure that you're copying them down accurately. And then we'll change R1. So R1 plus 0, 1. 3 plus negative 3, 0. 0 plus 0, 0. Now we got 1 plus negative 3. It's going to be negative 2. 0 plus 0, 0. And then 0 plus -3, we'll have -3. So, what we get here, we have the identity matrix on this side, and we have A1, A inverse on this side. So your A inverse is equal to -2, 0, -3, 1, 0, 1, -1, 0, 0. So we can do another example of that. Go ahead and pause your screen and try to solve. So first thing we're going to do is set it up against that identity matrix. And we'll go a little quicker on this one. So first thing we want to do, get rid of this 5. So we'll do R3 plus -5R1. So we know this one stays the same. This one stays the same. And we'll change this one up. So 5 plus -5 is going to be 0. 6 plus -10, -4. And 0 plus -15 can be -15. Here we go. 0 plus -5, -5. 0 plus 0 is 0. And 1 plus 0, 1. All right. Now, what we can do is we can get rid of this 4 here, make this one a 0 using row 2. So we'll do R3 plus 4 R2 to make that 0. We know row 1 and 2 stays the same. And we'll change R3. 0 stays the same. -4 plus 4 is 0. -15 plus 16, 4 times 4, can be 1. -5 plus 0, -5. 0 plus 1 times 4, we have 4. And we'll keep this one a 1. Let's bring it down to this side. So now we have 1, 1, 1. Now we just need to get rid of this 4. We're going to get rid of this 3 and this 2. So we'll start off with row 1. We're going to change row 1 by adding 2 row 2. Well, -2 row 2. So we'll keep R2 and R3 the same. and we will change R1. We're gonna have 1, 0, 4 times -2 is -8 plus 3. We got -5. We have 0 plus 1. And keep this 1 a 1. We're going to do -1 times -2 plus 0, -2, 0, 0. Keep that a 0. And now let's do 2 at once this time. We're going to change row 1 and we're going to change row 2. Using row 3. So for row 1, that's going to look like this. Row 1 plus 5, row 3. And that's going to be row 2 plus -4, row 3. Keep row 3 the same. 0, 0, 1, 5, 4, 1. Yeah, we have 1. Oops. We have 1, 0. 5 plus 5, we have 0. So we're going to do -5 times 5. We have negative. Okay, so we have -5 times -5 plus 1, -24. We have 4 times 5 is 20, plus -2, we have 18. And then we have 5 times 1 is 5, plus 0, we have 5. Then for row 2, we have R2 plus -4. So we have 0, 0, we'll keep that 0. 0, 1, keep that 1. And then 1 times -4 is -4 plus 4, 0. We have -5 times -4 is 20 plus 0. We have 20. We have -4 times 4 is -16 plus 1, -15. And last but not least, we have 1 times -4 is -4 plus 0, -4. So our final inverse matrice is equal to -24, 18, 5, 20, -15, -4, -5, 4, and 1. Thank you so much for watching, and if you found this helpful, please like and subscribe.